In this example, it seems fairly obvious. 10.3 minus 2.2 should be 8.1. So we should be able to compare these, and they should be equal. But let's see what happens. So notice num3. All floating point values, whether double or float, are approximations. Recall that they're finite in size, but we're trying to represent infinitely small numbers and infinitely large numbers. So everyone is an approximation, and that's what's happening here. The result of the subtraction is an approximation, but this operator is comparing exactly. And so these are not equal. The summary is, don't compare floating point with equals or not equals, because it's likely not accurate, or it could be inaccurate. And so how we do this, so what we want to do is define some difference that's tolerable for our problem. So if we're dealing with very large numbers, then a small number that it's like if it's less than this, we consider those the same. So it depends on your problem what your epsilon is. But then we change this comparison. So instead of being this math dot, let's do the absolute value of the difference between these and see if it's less than our epsilon value. So what we're trying to compare, see the absolute value of the difference, how close it is. If it's less than some number where we said close enough, then we consider it equal. And so this is the way to compare floating point numbers. So we've got the differences, epsilon, it is less than the epsilon, much less. And so these are considered equal. So in short, comparing floats, don't use equals or not equals, but compare with what's the absolute value of the difference. Is it less than some value that makes it insignificant for your problem?